All right, let's lift the hood on Google's software engineering machine today. We're going to be diving into Software Engineering at Google, a book that gives a peek into, well, how they build and maintain software at scale. I mean, it's Google.
And it's more than just like the tools and tech. It's really about the philosophies behind how they approach, software engineering in general.
Yeah, that's a great point. It's not just about the what, but the how and the why.
Exactly. And one of the first things that really stood out was their distinction between, just programming versus real software engineering. It's subtle, but super important, I think.
Yeah, that's interesting. Can you elaborate on that a bit? What do they mean by that?
Sure, sure. Think of it this way. Programming is like, whipping up a quick meal for yourself. You have the ingredients, the recipe, you eat, you're done.
Okay, I'm following. Where does the engineering part come in?
Well, imagine now you're not cooking for yourself, but for a whole city. You need to worry about ingredients at scale, keeping things consistent, handling, a million different dietary needs, and making sure the whole thing runs smoothly every single day.
Right, right. So it's about that long-term vision, thinking ahead.
Totally. And the book uses this great example. Imagine Google search still running on like a 1990s operating system needing an upgrade. You wouldn't care if it was just some Python script you wrote once and never touched again.
Yeah, a one-off thing? Makes sense.
But for something as massive and constantly evolving as Google search, that kind of change, it's huge. It takes meticulous planning, testing. You need to know how it all fits together.
It's mind-blowing to think about all the moving parts involved there.
Oh, absolutely. And that's where time becomes this key factor in differentiating programming from software engineering. They have this quote, software engineering is programming integrated over time. Really sums it up well.
I like that. So how does Google actually handle these long-term challenges? What are their secrets?
Well, they have this fascinating concept they call Hyram's law. It basically says that no matter how well you document an API, once you have enough users, someone, somewhere, will find a way to depend on like even the tiniest quirks or unintended behaviors.
So it's like you can't account for every possible use case.
Pretty much. Like you can try, but with systems as complex as Google's, there will always be unforeseen dependencies. The book tells this great story about a compiler upgrade they did back in 2006. They spent years making sure it was backward compatible, but once it rolled out, all sorts of weird issues popped up because, well, developers had come to rely on some, let's say, unintended features of the old compiler.
Sounds like a nightmare. How do they even deal with that?
It was a huge lesson for them, that's for sure. Really drove home the importance of Hyram's law, and they learned to build strategies around it, like expensive testing, clear communication, and, get this, humility.
Humility. In software engineering. Explain that one.
Yeah, it's refreshing. The book really emphasizes that everyone makes mistakes. Even, Google engineers, they push for a data-driven culture where you constantly revisit decisions as new information comes up. Being wrong isn't a failure. It's just, part of the process.
So it's about adaptability, being willing to change course.
Exactly. Like they say, even with data, decisions need revisiting. Leaders admitting mistakes is key. It's a much healthier way to build sustainable systems in the long run.
Makes sense. So it's not just about being right. It's about being able to admit when you're wrong and learn from it.
Exactly. And that actually leads to another important point they make, which is the whole idea of teamwork and collaboration. They debunk this myth of like the lone geniuses programmer.
Yeah, the lone wolf coding all night, solving every problem. We've seen that in movies.
Yeah, and they're saying that's not how it works, especially not at Google. They compare it to having a compiler that's constantly giving you feedback, helping you catch errors early on. Teamwork amplifies everyone's strengths.
It's like having a built-in code review, but with real people.
Exactly. And it's not just about the technical side either. They talk a lot about Google's culture, specifically this idea of humility, respect, and trust. They even have a term for it, being googly.
Being googly. Sounds intriguing. What does that even mean?
Well, it goes beyond just their old motto, don't be evil. It's about fostering this environment where everyone feels comfortable sharing ideas, asking questions, admitting they don't know something. They call it creating psychological safety.
Psychological safety. I like that. It sounds so much more tangible than just saying good culture.
Yeah, it's not just a buzzword. They give real examples of how this translates into their engineering teams. Like they talk about giving constructive criticism in a way that focuses on, improving the work, not attacking the person.
Right. So it's not your code is garbage. It's, hey, we could make this code more readable if we did X.
Exactly. It's about framing feedback to be helpful, not demoralizing. They even tell a story about using metaphors to give tough feedback in a way that, really resonates with someone.
Metaphors? Like what?
Well, there was this one manager who was trying to give feedback to an engineer who was like really resistant to change. So instead of, directly confronting him, he used this metaphor of a tree that needs pruning to grow stronger.
Oh, I like that. It makes it less personal and more about the bigger picture.
Right, and the engineer actually responded really well to that. It's about recognizing that everyone has something to offer and creating a space where they can, do their best work.
I love that. It makes a lot of sense. And speaking of doing your best work, they also talk about the qualities of great managers at Google. They emphasize hiring people smarter than yourself and actively dealing with underperformance. Sounds like they have pretty high standards.
They do, and they're not afraid to talk about the tough stuff, like giving difficult feedback, handling low performers, building a culture of accountability. It's not all sunshine and rainbows.
Right. But it sounds like they're trying to create an environment where people feel empowered and trusted to do their best.
Absolutely. They believe that the best managers are those who can step back and let their teams figure things out while still providing, guidance and support.
It's about finding that balance, giving people freedom to innovate while still keeping everyone aligned with the overall goals.
Yeah, and that's tough, especially at Google scale, but they've managed to create systems and processes that allow for both.
So they're not just about, the technical stuff. They've really put a lot of emphasis on the human side of software engineering.
Yeah, definitely. And they even have a whole section dedicated to making waves, encouraging people to tackle tough situations head on. They argue that ignoring problems doesn't make them go away.
So if you see something wrong, say something.
Exactly. They believe in speaking up, challenging assumptions, pushing for improvement. It's about being a good citizen within the organization, not just a good coder.
I like that. It's about taking ownership, being proactive. So how do they actually measure something as complex as, engineering productivity? Seems almost impossible to quantify.
It's tough, but they have a framework they use called Goal Signals Metrics, or GSM for short. It helps teams choose metrics that actually align with their goals, not just vanity metrics that don't really tell you anything.
Okay, break that down for me. What are goal signals metrics exactly?
So your goals are the big picture things you want to achieve. Signals are indicators you're moving towards those goals, and metrics are how you actually measure those signals.
So like if your goal is to increase user engagement, your signal might be, more time spent on the site, and your metric would be the average session duration.
Exactly, and the book gives tons of advice on picking metrics that are actually meaningful and actionable.
That's super helpful. It sounds like a valuable framework for any team, not just Google.
Definitely, GSM can be applied to any team that wants to understand and improve their work process.
Speaking of improvement, they also talk about their famous readability process and how that contributes to code health. And it's not just about making the code look pretty, right?
Nope, it's much deeper than that. They believe readable code is crucial for maintainability and collaboration in the long run. If it's easy to understand, it's easier to work with. They have whole teams dedicated to reviewing code for readability.
So it's like having a grammar editor, but for code.
Yeah, kind of. And they have these really interesting examples of how, seemingly harmless code can actually cause problems down the line, like performance bottlenecks or hidden bugs. The readability process is all about preventing those issues.
Makes sense. It's about catching those problems early before they become a bigger headache.
Exactly. It's about investing in code quality from the start.
I'm already feeling a little overwhelmed, to be honest. There's so much information here. It's like drinking from a fire hose.
I know, right? And we've only just scratched the surface. There's so much more to cover.
Well, then buckle up. I'm ready for more. Let's talk about code reviews, style guides, all that good stuff.
Let's do it. All right, so let's dig into code reviews at Google. It's not just about finding bugs. It's really ingrained in their culture. It's how they ensure code quality and, spread knowledge around.
So it's a pretty big deal over there, not just a quick glance at the code.
Oh yeah, they have whole systems and processes for it. It's taken seriously. They see it as a chance to learn from each other, mentor, and just make the entire code base better.
I heard they have this internal tool called Critique, right? It sounds intense.
It's pretty amazing, actually. Critique handles a lot of the, tedious stuff, like suggesting reviewers, running those automated checks and stuff. It even ties into their bug tracking system, so you can keep tabs on, issues found during review.
So it's like a code review assistant on steroids.
Pretty much. And it means reviewers can focus on the bigger picture stuff, like design choices and potential long-term issues. Giving good feedback is super important, and Critique really helps with that.
Makes sense. They also talk a lot about style guides and rules, right? Keeping the code consistent and readable.
Yeah, style guides are crucial. They have specific rules for naming things, formatting the code, even how you write comments. The idea is that consistency makes it easier for everyone to understand and work with the code.
So it's like having a shared language for the whole engineering team.
Exactly. But they also realize that, not everything needs to be a hard and fast rule. There's a balance between best practices and letting teams have some flexibility when it makes sense.
Right. It's got to be adaptable to different teams and projects. one size doesn't fit all.
And speaking of different perspectives, they highlight how important that is in code reviews, too. They encourage getting feedback from folks with, diverse backgrounds and skill sets.
So it's not just about getting another pair of eyes on the code. It's about getting a different perspective, someone who might catch things you wouldn't have.
Exactly. And it's a great way to learn new stuff from each other. Knowledge sharing is huge at Google.
And along those lines, they also talk about documentation, right? Making it a core part of the development process.
Yeah, documentation is often an afterthought, but at Google, it's essential. It's all about sharing knowledge, helping new folks onboard, and making sure the code base stays healthy in the long run.
So it's not just dry technical specs. It's about creating something that's actually helpful and maybe even a little engaging.
Right. They have different types of docs for different things. Reference guides, design docs, tutorials, you name it. They even have a whole system for removing outdated docs to prevent confusion.
Wow, that's serious dedication to docs. It sounds like they've really thought it through.
Oh yeah, and they're big on writing clear, concise documentation. They even have style guides for that. Good docs are seen as an investment in the project's success.
It's like they're saying if you can't explain it clearly, you probably don't understand it well enough.
That's a good point. Writing docs really forces you to solidify your thinking. It's valuable even if you're not at Google.
Okay, so we've covered code reviews, style guides, and documentation. What about testing? I imagine that's a pretty big deal at Google, too.
Oh, huge. Testing is deeply ingrained in their culture. They have a saying, test everything, test always.
I bet they have some pretty crazy tools and infrastructure for testing.
Oh yeah, they have this whole system for running automated tests at all levels, like from the small unit tests to big system level tests. They even have dedicated teams focused on testing infrastructure.
It sounds like a tester's dream come true.
It kind of is. They believe that testing is essential to making sure their software is, top-notch, reliable, and they put their money where their mouth is.
So what's their overall philosophy on testing? What are the key things they focus on?
Well, one of their core principles is that tests should be fast and give you the same results every time, no matter where you run them. Consistency is key.
Yeah, slow or inconsistent tests can really bog down development.
Exactly. They've set up their systems to run tests in parallel and keep them as isolated as possible so they're quick and reliable.
And they have this interesting concept of different sizes of tests, right? Small, medium, and large. What's that all about?
That's how they categorize tests based on how much they cover and the resources they need. Small tests are usually those little unit tests that check individual function in their modules. Medium tests look at the interactions between different parts. And then large tests check the whole application from end to end.
So it's like a period, right? Lots of small, fast tests at the bottom, and then fewer, more complex tests as you go up.
Yeah, that's a great way to picture it. They have specific guidelines for what kind of tests should be in each category. It's all about having a good mix to catch different types of problems.
So they're not just throwing a bunch of random tests together. There's a real strategy to it.
For sure. And they've got all sorts of best practices and tools to help folks write effective tests. Plus, dedicated teams to handle the infrastructure so the engineers can just focus on writing good tests.
It's clear they really take testing seriously. It's baked into their whole process.
Oh yeah, it's not just an afterthought. It's part of their engineering DNA.
Okay, but how do they actually put this into practice? Any specific techniques or tools they use?
One of their most famous initiatives was called testing on the toilet. Sounds a little weird, right?
Testing on the toilet. Wait, were they actually writing code in the bathroom?
Not exactly. It was more about making testing, accessible and even a little fun. They'd post these bite-sized testing tips and quizzes in the bathroom stalls, Encourage people to think about testing even during their downtime.
That's pretty clever, turning those little breaks into learning moments.
Yeah, and it really hammered home the point that testing is everyone's responsibility, not just the dedicated testers.
So it was as much about changing the mindset as it was about the technical stuff.
Definitely. They also had things like orientation classes for new hires, all about testing, and this test certified program where teams could earn badges for doing awesome testing.
Wow, they went all in on building that testing culture. And it clearly paid off looking at how solid their products are.
Absolutely. They see testing as an investment in the long-term health of their projects. It's something any team can learn from, big or small.
So what are the main takeaways for our listeners when it comes to testing? How can they improve their own processes?
Well, first off, everyone needs to be involved in testing. It's not just for the testing specialists. Developers need to be writing and maintaining tests, too.
And keep those tests fast, consistent, and well organized. And maybe try something fun like testing on the toilet to get the team engaged.
Exactly. Make testing a natural part of the process, and it'll be less of a chore.
Okay, we've covered testing pretty thoroughly. What about some of the other challenges Google faces, like dependency management, or dealing with those huge code changes.
Oh, those are big topics for sure. They've got a lot of interesting things to say about those. But I think we've covered enough for one episode. Maybe we can dive into those another time.
Yeah, that's probably wise. We've already thrown a ton of information at our listeners. We'll definitely have to revisit this book in a future episode.
Sounds good to me. There's always more to learn from how Google does things.
All right, so we talked about testing as crazy code reviews at Google, and even how they handle all those dependencies. What else is there to uncover in this Google software engineering world?
Well, next up is the world of continuous delivery and deployment. Google is all about getting those updates out there fast, like release early, release often. That's their motto.
Okay, that makes sense, but doesn't that put a ton of pressure on the engineers? I mean, constantly releasing new stuff. Sounds kind of stressful.
You'd think so, right? But they actually found that releasing more often actually helps with work-life balance. No more like all-nighters to get a big release out the door.
I see, so it's more of a steady flow than these big, stressful pushes.
Exactly. Smaller releases more frequently. And they've built their whole system around it. They use this thing called dynamic deployments, where they can release just the parts of the code that are actually being used. Pretty smart, huh?
That's really cool, so they can target specific features or users with each release.
Yep. Makes them super agile and responsive. It's like their software delivery system is as flexible as the code itself.
That's impressive. It sounds like they've really thought through every step of the process, from writing the code to getting it in front of users.
They've got it down to a science, and they're always tweaking and improving things, always experimenting. It's part of what makes them so innovative, I think.
And speaking of innovation, now we're going into, like, the final frontier. Compute as a service. It sounds futuristic.
Right. It's a far cry from those days of managing servers manually. They've built these super sophisticated automated systems that handle like everything from setting up servers to deploying code to keeping an eye on how it all performs.
They have this system called Borg, right? It's their cluster management system. What's that all about?
Borg is like the brains of their whole infrastructure, manages a massive amount of servers, allocates resources where they're needed. Super complex, super powerful. It's what lets them scale their services to like billions of users.
It's hard to even fathom that kind of scale. And they have this interesting analogy for how they approach servers, right? Something about pets versus cattle.
Oh yeah, that's a classic. Back in the day, they used to treat their servers like pets. Each one had a name, they'd pamper them, and if one went down, it was a big deal. But as they grew, that approach just didn't work anymore.
So they shifted to treating them like cattle. Interesting.
Exactly. With cattle, you don't get attached to individual servers. They're all the same, easily replaceable. If one goes down or a problem, the system just spins up another one. It's all about being resilient and scalable.
It's like a self-healing data center.
Exactly. That's a great way to put it. That cattle mentality has been key to their growth.
It's wild to think about all the work that goes into building and managing that kind of infrastructure. It's a whole world of software engineering that most people don't even know exists.
For sure. And they're always pushing the limits, finding new ways to make it all work better.
And it doesn't stop at Borg. They're into serverless architectures too, right? What's their take on that?
Serverless is relatively new, but it's basically where you don't have to manage any servers at all. You just write your code, deploy it, and the platform handles everything else. Scaling, security, the whole 9 yards.
That sounds amazing. Like software development on easy mode.
It has the potential to be really transformative. Less developers focus on the code, not the infrastructure. It's more agile and can save money too.
So are they like all in on serverless at Google?
They're investing a lot in it, that's for sure. But they also know it's not perfect. There are still challenges like managing dependencies in a serverless world.
Right, like with any new tech, there are trade-offs. You got to know what you're getting into.
Totally. And they're also looking at other cool stuff like containerizations and microservices. It's a really exciting time to be a software engineer.
Well, we've certainly covered a lot of ground in this deep dive into software engineering at Google, from the basic principles of software engineering to their mind-blowing infrastructure. We've seen what makes Google tick.
It's been a wild ride. What are your biggest takeaways?
For me, it's the sheer scale of it all and their obsession with always improving. They're constantly innovating, pushing the limits, but they're also super disciplined in their approach.
I totally agree. They've shown that you can build amazing software at scale without sacrificing agility or innovation.
So what does this all mean for our listeners out there? How can they use these ideas even if they're not working at, Google level scale?
That's the key question. Think about the principles we've talked about. Are you treating your servers like pets or cattle? Are you embracing continuous delivery? Are you building a culture of knowledge sharing and psychological safety on your team?
These are things that every developer and every team should be thinking about. If you found this deep dive helpful, I highly recommend checking out the book, Software Engineering at Google. It's full of great insights and practical advice to make you a better software engineer, no matter where you work or what you build.
And remember, this is just the beginning. The software world never stops changing. So stay curious, keep learning, and always try to improve your craft.
That's a wrap on our deep dive into software engineering at Google. Thanks for joining us, and we'll see you next time on The Deep Dive.